Alright, today we're going to be talking about limits. So what is a limit? A limit is basically a y value that a function tends to go to as you approach a certain x. So a function approaches as x approaches a number. This is a very basic definition, but that's okay. We start with a basic word definition. If I want to talk about this graphically, if I have a function that looks like this, let's say this is some number a and this is some number L. What I would say is the limit as x approaches a of this function is L. Because as I approach a, in this case from either side, it's approaching a y value of L. We have two kinds of limits. We have one-sided limits. We indicate that a limit is one-sided by using sort of a plus or a minus sign in the exponent position of whatever the x value is that the function is approaching, or whatever x value is being approached. This is read as the limit of f of x as x approaches a from the right. It's from the right because it's from the positive side of a. Similarly, if we take the limit as x approaches a, we indicate the limit as x approaches a from the left with the minus sign in the exponent position of the x value. So this would be the limit of f of x as x approaches a from the left. As long as these approach the same value, a two-sided limit exists. So in other words, if the limit as x approaches a from the left for a function equals the limit as x approaches a from the right of a function, as long as these both equal the same value L, then the two-sided limit exists. And we would write the two-sided limit without anything in the exponent position here. So technically, when we ask you to check for the limit, you need to check it from the left or right. There is one exception, that's limits that go from negative as x approaches negative infinity or positive infinity. Because there is nothing left of negative infinity or nothing to the right of positive infinity, any limits as which x approaches either negative infinity or as x approaches positive infinity are one-sided limits. So it is important to indicate or be careful as far as whether it's approaching from the left or the right, because we do have questions that involve graphs that look like this. So in this case, the limit as x approaches 1 from the left of the function, I would do this by basically going to 1, look as I'm approaching to the left. So I'm left of 1, going to the right towards 1, and I see which y value it approaches. In this case, it approaches 3. the limit of this function as x approaches 1 from the right, I would go to 1, and now I would approach it from the right side, going left toward 1. Now the function is approaching a value of 1. Because these are not the same value, if I am asked for what the limit as x approaches 1 of the function is, remember that's a two-sided limit, I would say this is undefined or does not exist. The two-sided limit only exists if the two one-sided limits converge to the same value. Now we do have a couple slightly stranger limit cases to consider. One is infinite limits. These are tied with the idea of a vertical asymptote. So if I have a limit as x approaches a number from the left, or a limit as x approaches a number from the right, if these limit values equal infinity or negative infinity, then it is true that x equals a is a vertical asymptote. So graphically, if I have a function that looks like this, I can see that x equals 2 is a vertical asymptote, but the reason formally it's a vertical asymptote is the limit as x approaches, let's say 2 from the left, equals infinity. That's enough for me to say it's a vertical asymptote. The behavior on this side does not matter. All I need is for the function to approach either infinity or negative infinity from one side for it to be a vertical asymptote. If the function looks like this, doesn't matter that the function is not going to infinity or negative infinity as x approaches 2 from the left. Because it's going to negative infinity as x approaches 2 to the right, that's sufficient for x equals 2 to be a vertical asymptote. Now how do we actually calculate infinite limits? The notation for this can be a little bit strange. Let's say I have a function that looks like this. So the graph of this is going to end up looking like this, and if you remember enough graphing from pre-calc, you'll be able to figure out the graph is this, and it should be evident that there's a vertical asymptote here. But let's say you don't know that. Let's say you are asked not necessarily to find a vertical asymptote, but just to evaluate the limit as x approaches 4 from the right of this function. Well, how do I do that? Let me just explicitly click that in. So one way to show this is to think of this as 4.001. So if I were to plug this in, I end up with 1 divided by a fairly small positive number. And so because as I get closer and closer to 4 from the right, this number is going to be 4.00001. Right, this number will get smaller and smaller but stay positive. So 1 divided by a small positive number will be infinity. And we can see that from the graph here. Now, this is clunky because it's not 4.001. It's arbitrarily close to 4 on the right. So another way you can show your work on this, with the caveat that you follow whatever requirements or rigor your teacher wants you to show. If I know I'm plugging in a number a bit bigger than 4, I know this is going to be 1 over a small positive number. And so 1 divided by a small positive number is going to go to infinity. Conversely, if I looked at the limit as x approaches 4 from the left, I know I'm plugging in a number, a little bit less than 4, like 3.999. So this will end up being 1 over a small negative number. 1 divided by a positive 1 divided by a small negative number will be negative infinity. Note that these are going to two different infinities, therefore the limit as x approaches 4, the two-sided limit of this function, does not exist. This is not proper notation, however, you can make use of either explicitly plugging in a number a little bit bigger than 4, or just writing small positive or small negative to help you remember how this works. Do note that the sign of the numerator does matter. If this were a negative number divided by a small negative, this would go to positive infinity. We also have limits at infinity. So how do we evaluate a limit as x approaches infinity of a function? It depends on the kind of function. Typically, we will deal with rational functions initially. This is a polynomial divided another polynomial. The way that we can figure this out is we can use basically the leading term and look at which one wins. The way we do this formally is we basically factor out the largest, we look at the largest power on the top, largest power on the bottom, and we factor out the smaller of the two. So x squared, x cubed. If I factor out an x squared from both of these,